Today, we will explore the fundamental concepts behind how web browsers communicate with web servers using the Hypertext Transfer Protocol, commonly known as HTTP. We will examine web page structures, HTTP connection modes, message formats, and additional features like cookies and proxies. A web page is composed of multiple objects. These objects can include HTML files, images, JavaScript code, video files, and more. At the core of every web page is a base HTML file that references or calls these objects. Each of these objects is uniquely identified by a URL, which consists of three main parts: the application protocol, the network address of the server, and the specific resource being requested. HTTP is the web's application layer protocol. It follows a client-server model where the client, typically a web browser, requests web objects, and the web server responds by sending these objects back. This is the fundamental mechanism behind how web pages are loaded. HTTP operates over the Transmission Control Protocol, TCP. When a client wants to retrieve a web page, it first establishes a TCP connection with the server, typically on port 80. Once connected, HTTP messages are exchanged between the client and the server, allowing the page's objects and control messages to be transferred. After communication is complete, the TCP connection is closed. Importantly, HTTP is a stateless protocol, meaning the server does not retain any information about past client requests. This simplifies server operations but also introduces challenges for maintaining user sessions. HTTP supports two primary connection modes, non-persistent and persistent. Non-persistent connections establish a new TCP connection for each request-response pair, which can increase overhead and latency. In contrast, persistent connections maintain an open TCP connection for multiple requests and responses, improving efficiency and reducing delays. In non-persistent HTTP, used in HTTP version 1.0, each request and response pair operates over a separate TCP connection. This means that every time a browser requests an object, whether it is an HTML file, an image, or a script, a new TCP connection is established. Once the requested object is successfully transferred, the connection is immediately closed. For web pages that contain multiple objects, such as images, style sheets, and scripts, this process must be repeated for each individual resource. As a result, multiple TCP connections are required, which increases network overhead and latency. The repeated opening and closing of connections introduce additional delays due to the time needed for connection establishment and termination, ultimately slowing down web page loading times. In a persistent HTTP connection, a single TCP connection remains open for multiple requests and responses between the client and server. This eliminates the need to repeatedly establish and close connections, improving efficiency and reducing latency. By default, in HTTP version 1.1, requests are sent in series, meaning the client sends a request and waits for the server's response before sending the next one. While this method is more efficient than non-persistent connections, it can still introduce delays when loading multiple objects. With HTTP pipelining, which is also supported in HTTP version 1.1, the client can send multiple requests without waiting for previous responses. This allows for faster data retrieval and improves web page loading times. However, not all servers and intermediaries fully support pipelining, which has limited its widespread adoption. Round-trip time, or RTT, refers to the time it takes for a small packet to travel from the client to the server and back. This metric plays an important role in determining the total transfer time for a web page in HTTP communication. For a single HTTP connection, the transfer time includes one RTT to establish the TCP connection, another RTT to send the initial HTTP request and receive the first bytes of the response, and the transmission time of the object itself, such as an HTML file or an image. When a web page includes additional objects, such as 10 embedded images, the total download time depends on the connection mode. For a non-persistent connection, each object requires a separate TCP connection. As a result, the total time can be expressed as the sum of 1 to 10 of two RTTs plus the single object transfer time. On the other hand, with a persistent connection, a single TCP connection remains open for all objects on the web page. In this case, the total time can be expressed as 1 RTT for TCP connection opening plus the sum of 1 to 10 of 1 RTT plus the single object transfer time. This mode eliminates the need for multiple connection setups, making it more efficient, particularly for web pages with numerous objects. By minimizing the number of RTTs required, persistent connections significantly reduce download times and improve overall performance. This diagram illustrates the sequence of events and timing involved in the HTTP request-response cycle, focusing on the time components of data transfer over a TCP connection. The process begins with the client, for instance a browser, initiating a TCP connection to the server. This step involves an RTT, which is the time it takes for a small packet to travel from the client to the server and back. Once the TCP connection is established, the client sends an HTTP request to the server, asking for the HTML content of the web page. This process involves another RTT, as the request travels to the server and the server begins sending the response. After the server processes the request, it begins transmitting the requested file, for instance the base HTML document. The time required for this step is the file transmission time, which depends on the file size and the network's transmission speed. Finally, the client receives the requested file. This diagram highlights the impact of round-trip times and file transmission time on overall page load performance. In this case, the total time for the process includes 2 RTTs, one for connection setup and one for the request or response exchange, plus the file transmission time. This diagram illustrates the structure of an HTTP request message, which is organized into distinct sections to communicate information from a client to a server. The first component is the request line, which contains 3 elements: the method, the URL, and the version of HTTP being used. The method specifies the action the client intends to perform, such as get, post, or delete. The URL indicates the specific resource the client is requesting, while the HTTP version, such as HTTP version 1.1, specifies the protocol version. These elements are separated by spaces and terminated with a carriage return and line feed. Following the request line are the header lines, which provide additional information about the request. Each header line includes a field name, such as host, user agent, and a corresponding value, separated by a colon. These headers allow the client to communicate preferences and parameters for the request, such as accepted content types or caching behavior. Multiple headers can be included, each on its own line, and the section concludes with a blank line. Finally, the entity body, which is optional, is used to send additional data with the request. This section is commonly included in methods like post or put, where data such as form inputs, JSON objects, or files need to be transmitted to the server. The entire structure of the HTTP request is encoded in ASCII and relies on specific separators, such as spaces and line breaks, to ensure the message is correctly passed and understood by the server. This organized format is essential for effective communication in the client-server model. HTTP defines several methods that a client can use to interact with a server. The most common method is GET, which is used to request data from a server, such as a web page or an image. POST is used to send data to the server, for example, when submitting a form. There are also other methods like PUT, which updates a resource, and DELETE, which removes a resource from the server. Each of these methods serves a different purpose depending on the type of interaction required between the client and the server. Headers are used to exchange additional service information. HTTP headers provide metadata about the request or response and play an important role in controlling the behavior of clients and servers. A single HTTP message can include multiple header lines, each containing a specific field and its corresponding value. For example, the cache control header conveys caching instructions, allowing the server to specify how and for how long the response should be stored by the client or intermediary caches. The accept header lists the formats that the client can handle, enabling content negotiation between the client and server. Similarly, the accept language header indicates the preferred languages for the response, which can be useful for delivering localized content. Other examples include the authorization header, which carries the client's credentials or permissions required to access a resource. The if modified since header allows the client to request a resource only if it has been modified since a specified date, reducing unnecessary data transfers. Finally, the user agent header provides information about the client software, such as the browser or application making the request, which can help servers optimize content delivery. This table provides a clear overview of common HTTP headers and their purposes, highlighting their role in enhancing the functionality and efficiency of web communication. This slide provides an example of an HTTP request message, showcasing the structure and content of its various components. The message begins with the request line, which specifies the GET HTTP method, the requested resource, index.html, and the protocol version, HTTP version 1.1. This indicates that the client is requesting the index.html page using the GET method under HTTP version 1.1,